Hey guys, it's Mr. Brown again. Quick video about finding trig ratios when you're given a point, an xy coordinate on the graph. So these are going to say something like the point 2, 3 lies in the terminal side of theta. Find the 6 trigonometric ratios for the angle of rotation. Something like that. That's kind of how they're worded. And they're actually a lot easier than it may sound when the way it's written. So first thing I want to do, I'm going to turn this into a triangle. We're doing right triangle trigonometry, so let's make a triangle. Our coordinate is 2, 3, so over 2, up 3, and it's right there. And let's make a line from the origin up to that point. Let's try to make a better line though. That's still not great, but whatever, it'll work. And let's make a line straight down and then connect it so we've got our nice little right triangle. Now, the base of that triangle is given by the x value, which is 2. The height of the triangle is given by the y value, which is 3. Then we just need to figure out what the hypotenuse is, and we can do that using Pythagorean theorem. A squared plus b squared equals c squared, where these two sides are a and b and the hypotenuse is c. So 2 squared plus 3 squared equals c squared. That's 4 plus 9 equals c squared. 13 equals c squared. So then c is the square root of 13. So our hypotenuse is the square root of 13. And we want to keep these in simplest radical form if we can. Now, the angle in this diagram is always right here, closest to the origin, inside of that right triangle. Then we can fill in our opposite sides, our opposite side, our adjacent side, and our hypotenuse. So now I can see how I can use SOHCAHTOA to figure out these different trig ratios. Our sine of theta is going to equal our opposite over hypotenuse, 3 over the square root of 13. Cosine theta is going to equal adjacent over hypotenuse, so 2 over the square root of 13. Tangent theta is going to equal opposite over adjacent, 3 over 2. Cosecant is the reciprocal of sine, so square root of 13 over 3. Secant is the reciprocal of cosine, so square root of 13 over 2. And cotangent is reciprocal of tangent, so 2 over 3. Now we're not quite done here, because notice I've got radicals, in the denominator. I don't have any fractions that will reduce, like if this were 4 over 2, I'd probably want to reduce that. If this were 2 over 4, I'd want to reduce that. But here I just have to multiply top and bottom by the square root of 13, and right here as well. And that'll make it 3 square roots of 13 over 13 for sine of theta, and 2 square roots of 13 over 13 for cosine of theta. Tangent is already reduced. This is in simplest radical form, this is in simplest radical form, and that's reduced. So these would be the final correct answers, are the ones that are all the way to the right. I think most of the math teachers, if the mistake is from at this point we didn't get into simplest radical form, we're probably going to give you the majority of the credit for the problem, but for full credit we'd want to see in simplest radical form. Now, one thing that you might be asking is, Mr. Brown, that worked really nice when it was 2 and 3, so it makes this nice positive value triangle. I'm going to give you a little shortcut here for some of the other ones that you might find. So let's say that instead of 2 and 3, we'll make this negative 3 and positive 4. And you might say, well, the other one worked out really well. It was, the base was 2, the height was 3, Positive numbers make sense for a triangle, but now -3, that doesn't make any sense. Well, it kind of does, because the triangle would just be flipped on the other side of the graph from here. But one shortcut we can take is that if we always use this triangle for these problems, I can take that x value, and I know x is the horizontal component of my graph, and I can put that -3 right down here. The y value, that's always the vertical component, so that's going to be right here. And now I can figure out with Pythagorean theorem what the hypotenuse is, and I can basically do the exact same thing we've been doing since the first day of 13.1. So I want to do -3 squared plus 4 squared equals c squared. Now be careful here, because if you just try to plug this into your calculator, you don't put parentheses around -3, it's going to give you -9, you're going to have a bad time, it's not going to work out. -3 squared is +9, plus 16 equals c squared, 9 plus 16 is 25 equals c squared, so c is going to be 5. Right? Now my ratios, it's still opposite, adjacent, and hypotenuse. So opposite over hypotenuse, 4 over 5. Adjacent over hypotenuse, -3 over 5. Opposite over adjacent, 4 over -3. Cosecant is the reciprocal of sine, so 5 over 4. Secant is the reciprocal of cosine, so -5/3. Doesn't matter where you put the negative, right? As long as it's in front, if it's in front of the 5, the 3, or in front of the fraction bar, it's all the same thing. And then tangent, cotangent, reciprocal of tangent, -3 over 4. And there you have it.